Okay, well, my welcome calculus class. Those of you that are watching this is a video solution for the interpreting the derivative worksheet, or I think it's called actually philosophical understanding worksheet, the derivative worksheet. So I'm just going to run through these. I'm actually going to do both worksheets in the same video because I don't think it'll take that long. So number one, it says suppose that the cost of drilling X feet for an oil well is C equals F of X dollars. So what are the units? So the thing we have to understand here is the independent variable is feet. So remember the derivative F, I gotta get that right first. There we go. The derivative is the same thing as change in y over change in x, right? So this would be the change in the dependent over the change in the independent variable. So in this case, number one, the dependent variable is dollars and the independent variable is feet, because I'm plugging in how many feet I've drilled to get out how many dollars it'll cost. So what are the units? That would be dollars per foot. In practical terms, what does this f prime of x mean? That would mean that it's telling me the change in cost per change in depth. So it's approximating how much it'll cost me to go another foot. What can you say about the sign? This is definitely positive. The further I dig, the more expensive it gets. So estimate the cost of drilling an additional foot starting at the depth of 300 feet, given that f prime of 300 equals 1,000. That means that if I was to drill another foot, it'll cost me another $1,000 on top of whatever else I've already been charged up to that point, right? So to go to 301 feet, it's going to cost me another $1,000. In that case, I might, if I was standing out there by the well, I might say, no, don't drill anymore. I've had enough. Okay. Number two, paint manufacturing company estimates that it can sell. So I think we talked about this one in class. I'm going to just run through it real quick. So what are the units? That would be gallons sold. Trying to go quick and it's not working. Gallons sold divided by dollars. I guess I don't need the sold if I'm just talking about units. It's just gallons per dollar, right? In practical terms, what does that mean? It means the change in, it's telling me change in number of sales per price increase. So how many more or less gallons I might sell if I increase the price of the paint, gallon of paint $1. What can you say about the sign? We've talked about this in class. It could be positive if the price is too low, and negative as price gets too high. And what can you say? What can you say about the effective increase the price from $20 per gallon to $21? So if the derivative is negative 100, that means at $21 per gallon, I will sell 100 fewer gallons than the $20 price. So by raising my price $1, I'm going to sell 100 less gallons than I did before. So this is very similar to the one we just did. Now it's units sold. I mean, it's cords sold. So this would be cords per dollar. Practical terms, what does it mean? F prime of P means, again, the change in cords sold per dollar increase. What can you say about sign? I don't know, with wood, I think it'd probably be negative. If you're selling wood and someone wants it, the higher your price is, the less you're going to sell, would be my assumption. I don't think people would be tricked into buying more by raising the price because they think somehow you have better wood. They could probably just look at it and say that's the wood I want or not, especially if they're just burning it. Okay, but you could argue with me on that. Given that f prime of 425 equals negative 2/5, what can you say about the effect of decreasing the price of a cord of wood? So if this says, from 425 to 420, so that means that, notice this slope here is essentially, if I raise the price $5, I'm going to sell 2 less cords of wood. If we think of like rise over run, right? Where the 5 is the change in the independent variable and the 2 is the change in the dependent variable. So that means if I lower the price from 425 to 420, I'm going to sell 2 less cords of wood, which goes against what I just said up there. But so my assumption is the derivative would not be negative. Oh, no, my bad. Let's erase that, back up. See, I make mistakes when I'm doing stuff further ahead. So yeah, this is a good illustration. So it is negative, like I said. So that means since I dropped the price, that means we'd have that means I have a negative $5 down here, which caused that to be a positive 2. So actually I would sell 2 more cords of wood. Okay. Moving right along, Yo-Yo Company, very similar idea. This is yo-yos per dollar. Practical terms, what does that mean in this case? It's the change in yo-yo cells per change in price. I think yo-yos are similar to the cords of wood, that's going to be negative. That the higher your price, the less yo-yos you're going to sell. Although now this one is contradicting what I just said. It says the change in the derivative is 1/2 when d equals 8. So that means that if I raise the price $2, I will sell 1 more yo-yo. So maybe 10 is the magic price. I don't know. What can you say about the effect of increasing the price? So if I go from 8 to 10, that means that I will sell 1 more yo-yo than I did when the price was $8. Temperature of a hot cup of chocolate sitting on a table in degrees Celsius. Okay, what are the units? That would be degrees per minute. In practical terms, what does that mean? It's the cooling rate of chocolate. Okay. What can you say about the sign? that is definitely negative. As time goes on, the temperature is going to get less. This says that for every 5 minutes, it drops 1 degrees. So if I only go 30 seconds, that's going to be a lot less. So another way to think of the negative 1/5 is for 1 minute, it drops 0.2. So if I only go 30 seconds, it's going to drop 0.1. So it will drop 0.1 degrees. Temperature of my chocolate. Okay, company's productivity in terms of items completed is a function of the number of people in. So this is N is the people working, and P is the number of products produced. So the units would be products, or you say units, I guess would be a better way to say that. Units produced. So that would be units of whatever it is per person. Practical terms, what does it mean? It tells me change in units produced per change in number of workers. What can you say about the sign? I think this is arguably could be negative or positive, because if you get too many people in there working, they could get in the way of each other, and it could go down. Or if you don't have enough people, you just don't have enough people to run it. So it depends on where you're at. It could be negative or positive. Given that the derivative is 300, so this is telling me that at this point, if I hire another worker, I'll reduce 300 more units. This says when n is 6. So right now I have 6 people working, so apparently maybe I need another person, because that seems like a pretty big increase. So if I was to go from 6 to 7, which means hire 1 more worker, I would produce 300 more units of my product. Okay, I'm going to switch over to the next one. So we talked about this in class a little bit. So basically what you're going to go through and draw representations of this. We did this in class. So like f prime of 4, that would be, I'm going to use red here because you can see it pretty good. Where's my draw? That would be like a line like that. Slope of f of x at 22. So that's again just the derivative at 22, or the slope, instantaneous slope at 22. I use a different color for that one. That's a lot steeper. This is just saying the slope at 28. Everyone see that's the instantaneous slope at 28. So that would be flat. I guess I should use a different color, like maybe orange. Fun. So that would be like right there, right? And so this is orange, this is green, and that's red, just so I can keep track, so I don't have to keep rewriting it. And this is going to be an average slope, the f of 20 minus f of 10. So we'll use, how about blue? That's pretty. So we're going from 10 to 20. Looks something like that. Oh, that's sloppy. So that's my blue. And then finally, we can use maybe, do I have a green yet? Dark green, how about purple? So the tangent line at x equals 14, that would be right here. So that's just a line like that. So now if we go back to just normal black, let's see. So it looks like we're supposed to go from smallest to largest, so the smallest number to largest number. This is the most negative steep slope, so that would be the smallest number. That one's, the blue is also negative, so that would be number 2. And then the orange is flat, so that'd be 3. And the green is steepest, and So that means this would be 4, and then that would be 5. Okay, part 2, illustrate each expression of the graph below by sketching a line with indicated slope. Average rate of change of t of d between 5th and 25th days. So here's the 5th day, there's the 25th day, and if I draw a line, it'll look something like, oh man, I cannot draw straight. Oh, that's embarrassing. Let me try that again. Okay, try that again. Here we go. Yeah, that's better. Okay, rate of change of t of d on the 15th day. So that's an instantaneous slope. So that would look something like this. And then this is, part C is just talking about the slope, instantaneous slope at x equals 12. So that would be right about there-ish. So it would look something like that. Okay. So let's see, this would be A, that would be B, and that would be C. Okay. P represents the amount of carbon dioxide. So we want to know the derivative at 1940, which would be right about there. Whoops, right about there. So I want to draw a line that's tangent, and it kind of goes through that point right there and that point right there. I think that's what we talked about in class. So that would be 330 minus 310, and it would be 1950 minus 1930, which gives us 20 out of 20, which is 1. So that's a slope of 1. That means every year the pollution goes up and the carbon dioxide units go up 1 part per million. Okay, and then number 4 says the speed of a car. So let's see. Use the difference quotient. So that would be 2 times the square root of 5 times 20.0001 minus 2 times the square root of 5 times 20. And of course, that would all be over 20.0001 minus 20. Not 220. Okay. So that's the difference quotient. And if we plug that in to our mind, okay, so if we want to calculate that in your calculator or off the top of your head, if you have that ability, that would be approximately 0.5. I think it comes out to be 0.499999375 or something like that, but we'd round off that off to 0.5. Okay, number 5 says, we got more. Oh yeah, we're not going to do those parts, just number 5. L is the light output, millions of lumens, and T is the time after ignition, milliseconds, of a number 22 light bulb. So you notice here that 5 milliseconds after the ignition of the light, it's 0.2 lumens, which is basically how bright it is. At 10 seconds, it's 0.5, 15 seconds, 2.6, 4, and then notice it trails off. So this is like a flash or something, apparently, that it produces some lumens. It takes a little bit of time to warm up. Of course, this is milliseconds, so it's not much time. And then it fades fairly quickly. So if they're to estimate L prime of 35, so an estimate would mean I would go out to 35, which is right here, and one possible estimate would just to take, say, 0.35 minus 1.7 and divide that by 40 minus 30, because that's an interval that contains the 35. Of course, you can get a better estimate here by a couple things, but this is just one way to do it. And if we do that, we end up with, if we do that, you'd end up with negative 0.135. And then it says give a practical interpretation. That means that we are estimating that at 35 milliseconds after the ignition of the light bulb, the brightness is decreasing because of the negative, decreasing 0.135 lumens per millisecond.